In this video, we write a C program to print 1 to n numbers using recursion, and also in this example we also see the stack involvement in the recursion. In the previous video, we have clearly discussed about the stack involvement in recursion. Now see, in this example we have a main function. Now first of all we see the output here. What is the program purpose here? Let us take we want to print numbers from 1 to n. If we take number 10, we want to print values from 1 to 10. Now in this example we have taken 20, that means we want to print values from 1 to 20. This is the output. To get this output, we have taken a display function which is taking n value and it is printing values. Now display function is made as a recursive function. In the main function we have taken the number, that is in this particular case that is 20, and then we have called function display of n. That means we are calling display function and passing n value. And now the display function, it is having code. If n is greater than 0, this is the base condition. If n is greater than 0, then again it is calling the same function display of with value n minus 1. Then it is printing. After calling display function, it is printing n value. This is the recursive code for printing 1 to n numbers using recursion. Now we see how this particular function is executed, and we see the analysis part, how we got this particular output. Now see this example. This is the main function, and once this particular function is called, let us say we are giving value n value 3. N value 3. Now we see how these functions are executed. Now display of n, this particular function is called. Now what is n value here? We have passed n value is 3. Now this n value becomes 3. Now what is the condition here? 3 value is greater than 0. So this condition becomes true. That means again we enter into if part, we enter into if block, and then it is calling display of n minus 1. What is display of n minus 1? N minus 1 means 2. Now again it is calling display of 2. Then immediately the control goes to display of n. Again another copy of display function is created. Now what will be the n value here? Here n value is 2. So why? Because display of 2 is called. Now here n value is 2. Now again the condition 2. If n greater than 0, 2 greater than 0, again it is correct. Then this particular statement is called, that is display of n minus 1. That means now another copy of display function is called. What is n minus 1 here? In this particular case n value is 2. That means display of n minus 1. 2 minus 1, 1. Again display of display function is called with value 1. Now 1 is passed here. In this particular case 2 is passed. Now what will be the n value here? 1. Now again if we go to display function, if n is greater than 0, now n value is 1, 1 is greater than 0, correct. Again it will call display of n minus 1. Now what is n minus 1? 1 minus 1, 0. Now again display function is called with value. What is the value passed here? 0. Now that means in this particular copy of display function n value is 0. Now observe that all these are local variables. This is local variable to this display function. Okay, all the n values are different. Why? Because they are assigned different memory locations. They are local variables to their corresponding function copies. Okay, now in this case n value is 0. Now n value is 0. If n greater than 0, 0 greater than 0, now this condition is false. Now this condition is false. That means now these statements are not executed. Now these statements are not executed. That means at this point of time When n value is equal to 0, that means when n value becomes 0, then we are stopping the recursion process. Then there will be no more recursive calls. Now what happens here? There are no other statements to execute after if statement. Now that means this particular copy of the function is completed. Now this particular copy of the function is completed. So once this is completed, now the control returns to its caller. Who is its caller here? Display of 1. Display of 1 is the caller. Then the remaining statements are executed in this function. Then what are the remaining statements here? Printf %d n. Now what is n value here? Now n value in this particular function is 1. That means we get output 1. Okay, I am writing output part. What is the output value we are getting? 1. Why? Because here n value is 1. Now this function is also completed. Now once this function is completed, that is display of 1 is completed, then control returns to its caller. Who is its caller? Display of 2. That means the remaining statements in display of 2, they are executed. Now this particular statement is executed. Now printf %d n. Now what is n value here? N value is 2 in this particular function. That means now what is the second output we get? 2. And once this function is completed, the control goes to its caller. The control returns to its caller. Who is the caller for display of 2? The caller for display of 2 is display of 3. Now control comes here and it will execute the remaining statements. Now what is n value in this function? The n value is 3. That's why we get output 3. In this fashion, the recursive functions are executed in the program. Now we see the stack involvement in the recursion. Now this is the code for recursive function, and as we discussed in the stack video, whenever we call a function, then its related code and the local arguments declared in that function, they will occupy memory in the stack. Now once this program is executed, then initially main function will be called and it is assigned memory in the stack. Then we have taken a variable n that is also given memory location in the stack. Here n is equal to 5, and then it is calling display function display of 5. Now what happens here? Now display function is called. Once it is called, again it will allot, again one copy of the display function is created and it will be placed in the stack. Here also another n variable is created whose value is 5. Now in the code, here n value is greater than 0, 5 is greater than 0, that means now it is calling display of n minus 1. It is calling display function and it is passing value n minus 1. So here n minus 1 means 5 minus 1, 4. That means immediately another display function is called. Now observe here, there is another statement which is not executed, that is print 5. Why? Because whenever a function is called, automatically the control goes to that particular function. Now another copy of display function is created with value 4 and it will be placed in the stack. Another n variable is created with value 4. Here also n value is greater than 0, 4 is greater than 0. That means now again display function is called with value 4 minus 1. Now another copy of display function is created and it will be placed in the stack. A new variable n is created with value 3. Here also n value is greater than 0. Then again display function is called with value n minus 1, 3 minus 1, 2. Now another copy of display function is created with value 2. Now another variable is created n with value 2. Again 2 value is greater than 0. That means now display function is called again with value n minus 1, that is 1. Another copy of display function is created with value 1. A new variable is created n with value 1. Here also n value is greater than 0. Again display function is called with value 1 minus 1, 0. Now another copy of display function is created with value 0. Here a new variable is created n with value 0. Now at this point of time, is n greater than 0 here? Now n is not greater than 0. That means there will be no more function calls. There will be no calling of display function. That means we are stopping the recursion process at this point of time. Now what is the base condition here? N is greater than 0. Whenever n value becomes 0, then we are stopping the recursion process, and there will be no recursive function calls. Now when this function is completed, then it will be removed from the stack. Then now the control comes to its caller. Who is the caller of display of 0? Now this is the display of 0 function. Then who is the caller of display of 0? That is display of 1. Once this function is executed, then the control comes to display of 1. Then what are the remaining statements in display of 1 that are left? That is print 1. So that's why in the output we get 1. Now once this function is completed, then it will be removed from the stack. Then control comes to its caller. Who is the caller for display of 1? That is display of 2. Now once this function is completed, I will take another color. Initially we got output 1, and coming to display of 2, then what is the remaining statement that is left? Print 2. Then 2 will be printed. Then once this function is completed, control returns to display of 3. That means display of 2 function will be removed from the memory. And what are the remaining statements that are left in the display of 3? That is print 3. Now we will get output 3. Once this function is completed, it is removed from the stack, and the control returns to its caller. Who is the caller for display of 3? That is display of 4. Then similarly, once this function is completed, what are the remaining statements in this particular display of 4? That is print 4. This is also printed, and the control returns to its caller, that is display of 5. Here also we print the remaining statements, that is 5, and then they are removed from the stack. And after completing this particular function, control returns to its caller, and the caller for display of 5 is main function, and this function is removed from the stack. And once there are no more statements left to be executed in the main function, that's why then main function is also completed, then it will also be removed from the stack. So in this fashion we got the output. This is how the recursive functions are executed. In this video we have discussed about how the recursive functions are called, and how they return values, and how the control is returned from one function to another function. And also we have seen an example of the stack involvement whenever recursive functions are called.